Hi, today we're going to talk about kinetic energy. What's kinetic energy? Kinetic energy, it is the energy of a motion. So any moving object contain kinetic energy. Like this boy here who's riding a bike, he's moving, so he containing a kinetic energy. Another example, if the pole is moving with a speed of 5 meter per second, so the pole, in case of moving, it contain kinetic energy. Okay, what about if the pole stopped at the ground and it will be at the case of rest? Is it contain kinetic energy? No. Why? Because it is in the case of rest, and rest it mean no moving, so no moving mean no kinetic energy. But if the same pole is going to move, this is mean it is contain kinetic energy. So this is what I mean by kinetic energy, and the shortage for kinetic energy is K dot E. Okay, so kinetic energy depends on two factors affecting the kinetic energy. Is it increase or decrease? First one is speed. As much as the object is a speeder, the kinetic energy become more kinetic energy inside the speeder object. Like a cheetah and a turtle, the cheetah has more speed. It's much faster, so it contain more kinetic energy. By the same way, the turtle actually is the fast or slow. The turtle is slow, so it contains less kinetic energy. So as you increase your speed, the kinetic energy increase. As you decrease your speed, the kinetic energy decrease. What about the second factor is the mass. If I have two boy here, both are riding with the same speed, but one riding a bike and another one is riding a car. Which one contain more kinetic energy inside its object that riding? Actually, the one that got more mass. The more mass, it mean more kinetic energy. The less mass mean less kinetic energy. So the two factors depend on kinetic energy is the speed. As you increasing speed, there's a more kinetic energy, and the mass, as you become larger mass, more mass, it mean you contain a more kinetic energy. So from the two factors, mass and velocity, we can calculate the kinetic energy. Kinetic energy equal half mass times velocity square. Again, kinetic energy equal to half mass times velocity square, where kinetic energy, it's measured with joule because it's energy, and we said any energy is measured with joule, and M for mass, and mass will be measured with kilogram, and V for velocity or speed or velocity, that's why we write the letter V, and it's measured with meter per second square. So kinetic energy for the object that moving, but if the object will be at the rest of the casing of constant or at rest, it doesn't contain any kinetic energy. So let's take a problem on kinetic energy. The fall has a mass of 100 kilogram and it's moving at 5 meters per second along the beach. What is the kinetic energy of the fall? I'm looking for the question. What is the kinetic energy? So I'm looking for KE, kinetic energy. Given, what's the given here? The numbers 100 kilogram is the mass, so M equal 100 kilogram. Okay, and 8 meter per second. I know meter per second is the unit for speed, so S, and here we have V. Velocity or speed will be equal 8 meter per second. The relationship, I will write the relationship K kinetic energy equal half M times V square. Okay, so let's substitution with the numbers. We're gonna write half. What is the M here? M with 100. Multiply. V, where's the speed? 8. Squared. You have to make it a square. Okay, half of 100 is 50, and 8 squared with 64. And use your calculator to find the answer. It will have 3,200, and the unit of kinetic energy is joule. So this is the answer for kinetic energy, and you have to check your unit. Now let's come to the opposite kind of energy, which is potential energy. As I told you before, if there's a stone on the ground and the stone in the case of rest doesn't move, it's a constant, so it contains no kinetic energy. And instead of that, it must contain another kind of energy, which called potential energy. Potential energy. This is the shortage of potential energy, PE. So what is potential energy? It is the stored energy. Stored mean it will be stored inside the object, okay? In the case of rest. So the definition of potential energy is the energy an object has because of two reasons: its position or its condition or chemical composition. Again, is the energy an object has because of its position, its condition, or chemical composition. We're not going to understand the definition without taking the three types of potential energy. Potential energy has too many types. We're going to take three of them. A first one is a chemical composition. There is a potential energy inside the fruits and vegetables due to its chemical composition. What does it mean, chemical composition? It means any object we know contain from its internal part with a small internal parts. We take it in semester 2. That parts is called atoms and molecules. Atoms and molecules, between those parts, there is an interaction between those internal parts. We called it bond. Okay, there is a bond between them, and that bond doesn't write well. Okay, that bond means there is an interaction between the internal parts, and that energy is stored till you release it. Okay, now if you don't eat the food or the vegetables, you're not gonna feel the energy inside the fruit or vegetables. But when you eat it and when you cut it inside your mouth and eat it and digest it, you're gonna feel the energy in your body. You can do your everyday's activities. Now you get energy. From where it comes, that energy? From the food you eat it. So the food contain energy. Why? Because it's chemical composition. And the chemical composition here is the reason for a potential energy due to the component, the structure of the food itself. Okay, this is the first kind. The second kind is gravitational energy. Gravitational energy when the object is high from the ground. This is the ground, and the object is high from the ground. It contains something called gravitational potential energy. What does mean gravitational potential energy? It's the energy comes from the center of the earth that pulls you down to the center of the earth due to the gravity. So the gravity pull the object that is at a high above the ground. So if the object is at the ground, touch the earth, does it have any gravitational potential energy? No, it doesn't have any potential energy. Why? Because as you increase the height, the potential energy of gravitational increase. And this one is due to position. This one is the reason of position, because its position above the ground has a height of the ground. It's much higher than the ground, so that's why it contains a gravitational potential energy. The third one is elastic potential energy. Elastic is come with the stretched objects like a rubber band, like a string, and so on. Here we have archers. The archers here pulls back the string and stretches it. Now we want to look at the string before it's stretched. At the case of rest, in that case it contains energy. you're gonna say it's not moving. So how does it contain energy? It's contain potential energy, which is a stored energy. It allow the energy. It comes out when you move that object. So when you let it go, the energy is going to release, and that energy is elastic potential energy. Okay. Let's come to, we're gonna focus on one kind, which is gravitational potential energy. We're going to know its law. The law of gravitational potential energy is PE equal mgh. M for mass, we're going to measure it with kilogram. G for gravitational acceleration. It means the acceleration due to gravity, and it is a constant value, which is 9.8 meter per second squared. Okay, it's a constant. We're not gonna give it to you in the problems because you have to memorize it. Okay, it doesn't change. The h is the height, and the height will be measured by meters. Again, potential energy, it's the energy stored inside the object at the case of rest. When the object at rest, it contains energy, but that energy called potential energy. How can I calculate it? I calculate it by mgh, mass, gravitational acceleration, height. And as we said, potential energy, when the object is touching the floor, touching the ground, it has zero potential energy. But where there is a height from the ground, when it is above the ground, it contains a lot, the maximum potential energy. Because if we want to, if you don't understand that one, let's write it with the mathematical numbers. Okay, we're going to substitute in that relationship. The mass, for example, the mass of that pole is 5 kilogram, for example. Gravitational acceleration will be 9.8, as I told you, it's a constant. And the height, does it have any height from the ground? No, it will be 0 times 0. So if I calculate all of this, 0 multiply all of that number would give me 0. So the potential energy of the object that in case of touching the ground will be equal to 0 as we multiply in that problem. So let's take a problem here. Practice question in your POC page 93. The cat has a mass of 4 kilogram and is 1.5 meters above the ground. This is the height, of course. What is the gravitational potential energy? So looking for gravitational potential energy. Given 4 kilogram, this is the mass, m equal 4 kilogram. And 1.5 meters above the ground, this is the h, height, 1.5 meters. The relationship, gravitational potential energy equal, going to shortage, m, you have to memorize the relationship, mgh. Let's substitution and get the number. M here with a 4 kilogram times G. Why the question doesn't give me G? Because you have to memorize it, because G is a constant value, which is 9.8. It's the acceleration of the earth, okay? The gravity. And the height here is 1.5. And if you calculate it, it's gonna give you 58.8. What is the unit of gravitational potential energy? Because it's energy, the unit will be in joule. So it's so clear here. Okay, so from the previous two examples, two kinds of energy, kinetic energy in the case of moving and potential energy in the case of rest, if I summation all of them, if I add the both of them, it will give me something called mechanical energy. So what is mechanical energy? It's the summation of kinetic energy and potential energy. So if we want to calculate or to get the relationship of mechanical energy, which is ME equal to. What is the relationship of kinetic energy? It's half m times v square, and we're going to put add as it is. And what is the relationship of PE? It's mg h. So this is the rule of mechanical energy. From that rule, we're going to get something, that the energy is going to transfer from one kind to another kind. The kinetic energy is transferred to potential, and potential is going to transfer into kinetic energy. So the object, as it move and become at rest and move, it's a change all its kind of energy. It doesn't be a constant energy at one time. For example, if the boy is moving right now, or he's just standing, okay? He doesn't do any kind of motion. So he's at rest. So he got what? Potential energy. If he's going to move, okay, while he's moving and keep moving, that potential energy is going to convert all of that potential energy into kinetic energy. Okay, then after he moves, he's gonna stop again. So the potential energy is going to transfer, the kinetic energy is going to transfer again to potential energy, and so on. So the energy is not be created and not destroyed, but it changed from one form to another form. And we want to mention thing here. If the potential energy increase, it means the kinetic energy decrease, and vice versa. If the potential energy decrease, the kinetic energy increase. Okay, you will understand it more by that example. Here I have a basketball. Sorry, it must be more wider. Okay, now the player was standing here and he pushed that ball like this. Okay, it kept moving forward, moving upward till it become at the most height here, which is 3 meters. And here 2 meters, and here 1 meters, and here 0 meters. At the maximum height here, the pole is stopped for seconds. It's stopped for 1 second. So when the object at rest, now it's stopped. Is it kinetic energy or potential energy? Yeah, it's true, because it's at rest, it will be potential energy. So the maximum energy at that case is potential energy. So the potential energy here in the table is 18 joule. And the kinetic energy, because it doesn't move, so does it have any kinetic energy? No. So what's the amount of kinetic energy? 0. Now let's calculate the mechanical energy. Mechanical energy, we will add kinetic plus gravitational potential energy. So it will be 18 joule. So the mechanical energy here is 18 joule. Now the pole is keeping moving downward. It's gonna fall now at 2 meters. The gravitational potential energy, I want you to think with me here. The highest distance from the ground, okay, it's 3 meters. Now that height decrease, okay, it's not become at the higher height. The height is going to decrease. So is it gonna become the same amount of potential energy, or it's gonna decrease? It's gonna decrease. Why? Because as you become near to the ground, your potential energy becomes smaller. As you get above and higher than the ground, the potential energy will be increase. So here, as we measure the potential energy, it's transferred from 18 to 12. It means as we going downward, the potential energy decrease. What about the kinetic energy? Here stopped, but if it fall, the speed of the pole increase, and we said if the speed increase, the kinetic energy increase. So if the pole is become speeder, faster, its kinetic energy will increase. So it's from 0 to 6. I hope you understand this one. Now we want to calculate the mechanical energy at that point. We're going to add kinetic energy plus gravitational potential energy. 6 plus 12 will also equal 18 joule. So the mechanical energy is constant. Now the pole is kept moving downward to 1 meters. What happened to the height? The height is decrease, okay? So what happened to potential energy? Also decrease. So we're going to realize it's decrease from 12 to 6. That's true. What happened to the kinetic energy? Kinetic energy, as it's moving downward, it's become faster. The pole has become faster. So what happened to kinetic energy? Increase from 6 to 12. That's so true. So what happened to the mechanical energy? 12 plus 6, we're going to add it, also 18. So mechanical energy is saved, is conserved. It doesn't change, it's a constant. At the end, when it touched the floor, as I told you, there is no height here, the height is 0, so the potential energy here is 0. And when the pole is touched the ground, it has the most speeder, the most fastest point here, so the kinetic energy will increase. So as we realize here, as I told you, the kinetic energy here increase. As you realize, it's 0, then 6, then 12, then 18. So increase in kinetic energy, and this one decrease. And if we add it, it will also give me 18 joules. So mechanical energy is something constant in any object. So any object has a constant mechanical energy. So what is the changing in the object? It's the kinetic and the gravitational energy. Hope you understand the lesson, and thank you so much.